Welcome to the next lecture series, which focuses on paleontology and the early primate fossil record. Well, first we need to understand what paleontology is and understand processes of things like fossilization and other things that we study like taphonomy and stratigraphy, which will be outlined in the first part. And then we'll move on to how we know how old things are and then into the early primate fossil record because after this part of the course, section 2, we're going to move into section 3, which is all of the fossil record for human evolution. Paleontology is the study of extinct organisms, that is, organisms that are no longer living. Their species do not any longer persist on this planet. This is in contrast directly to extant organisms, which are organisms that are still living. Paleontology is a challenging field because what you need to do is you need to study all of the living organisms as a model to interpret the organisms that you find in the ground because they're only bits and pieces of skeletal material. Entering the Leakeys, Mary and Lewis, they're like the first family of paleoanthropology, right? Looking at ancient humankind. That's a field of paleontology because these are fossils that are intermediary between apes and us, or even other early primate fossils. Yeah, we have lemur fossils that lived in the Americas 50 million years ago. We have tarsier fossils that lived in the United States 50 million years ago. That is paleontology, but it also falls in the umbrella of anthropology, right? Because we're studying primate evolution. The Mary and Lewis Leakey, the Leakeys, they worked at the Olduvai Gorge famously, which is an old ancient lake, which is a great place to find fossils because it is a low energy environment, and when things sink to the bottom of a lake, they're oftentimes covered in soot in an anaerobic environment, and they're kept away from the elements, and they are preserved. Now, a fossil simply is the preserved remains, impressions, or traces of past organisms. And a fossil is oftentimes something that is fossilized. That means that all of the organic material in that organism is now replaced with inorganic material like rocks and sediment. This is a fossil known as Archaeopteryx, which was one of the first fossils that gave us the indication that there was a connection clearly between birds and reptiles in the form of dinosaurs. So you can see the Archaeopteryx fossil is a bird that has a beak with teeth, and it also has a long bony tail, while most modern birds, have a much shorter tail. This also preserved some of the feathers because it's in an area where there's very fine silt and clays, and you can find this in areas in parts of Germany. And there's a few copies of this fossil, and we find even more of them now. So you can see that even some of the former soft tissue, like the feathers and the wings, have preserved. So sometimes this can happen, and it tells us about these organisms and how they once lived. So not everything that is the remnant of an organism is actually fossilized. So fossilization is where you actually have soft tissue that is mineralized. So you can see these two pictures, these two slides, where the one on the left is actually unfossilized bone. That's bone that you can find on any slide in a microscope, and then there's fossilized bone on the right. The structure is the same. Matter of fact, we have these canals or circles, which are known as Haversian canals. You don't need to know that, but our bones are porous, and as you age, they become more porous. That's typically what's known as osteoporosis. Osteobone, porosis, porosity, or little tiny holes. And what happens is, as you age, you get more of them. So in cross section, you can see in skeletal tissue these canals, and this is actually human bone. It looks like it. Nice Haversian canals, nice and wide. Human bone's very distinct, but you can see the structure is the same, but one's organic material and one's inorganic or rock. Taphonomy is an awesome field of study. It's actually the study of what happens to an organism from when it died to it being discovered and entering the fossil record. Understand that finding fossils super rare. We get excited about even finding a small fragment of a piece of a tooth, because that can already tell us lots of things. But if we find the more remnants of a single organism or an individual, mostly complete, like Lucy in the lower right corner, that's the on the red felt, that's the famous fossil Lucy, which we're going to know more about, which is the species, her species, Australopithecus afarensis. Uh, People have talked about that skeleton as being about 40% complete, and when you have more of one individual, you get a clearer picture and you can ask a lot more questions. So taphonomy is this important study that tells us about the distribution of fossils for the most part, and kind of the process between when the organism dies until it's actually recovered. And so when an organism dies, you also have scavenging, you have decomposition, you also sometimes have deposition. Not all organisms are actually deposited or covered in sediment that we can recover them. Sometimes they're completely sun bleached and all completely dust. And so then it also has to interact with that sediment while it's deposited, the right kind of sediment for it to fossilize in a mostly complete way. And then archaeologists, paleontologists, we find that stuff. That's recovery. Well, let's go through this process of taphonomy with a finer tooth comb. Let's expand it a little bit. An organism dies, like this zebra, on the plains of Africa, and then natural death or whatever disease falls over and is no longer living. And of course, we have all sorts of animals that will scavenge this creature, this dead carcass, and that includes any predator and any specialized scavenger. So understand one, like this image here with a lion that would consume a bit of this carcass. Yeah, many people think the lion is a great hunter, the pride land, but a lion and any other top level predator for that matter will actually scavenge a carcass. That's free meat sitting around, go for it as long as it's still good. And then you have other specialized scavengers like vultures and hyenas. And during this time, the carcass is being is decomposing. It's also being consumed by scavengers. It's little bits and pieces are being transported because a vulture may come down and peck little bits and pieces of a leg and gnaw off some ligaments and fly away with a piece of the bone. Same thing with a lion. Lion might take a chunk of that zebra carcass and bring it to some of his hungry cubs and drop it off. And so that's how we get bones kind of distributed all over the place and not of a single individual. And we also have other animals that will trample the carcass and the bones. And this can be, large animals like wildebeest or hippos that do this. Then if this carcass decays and all the soft tissue is gone, decomposed, all we have left is a skeleton, then what you might see is half the skeleton is deposited and the other half is actually exposed to the elements, to the sun, and bones will actually sun bleach. And I don't know if many things can sun bleach, clothes, if you leave them outside and expose the sun for an extended period of time. So bones will weather and they will crack and they will break, and this does not help in preservation. One of the important allied fields of geology is stratigraphy, and paleontologists and even archaeologists need to use the concepts of the study of rock layers, their sequence, and events that are reflective of time. So we use stratigraphic sequences, and the root word of this stratum is a layer of soil, or singular, plural is strata. And so stratigraphy is just the study of those layers of soil. And we need to do this in order to understand the type of depositional environment that a fossil is, and this also tells us about some of the best places to locate and find discover fossils.